Okay, if you look at it, -1 is -15. That's too big to fit on the graph, right? You go up to 6 or 5, 21, right? That's too big to fit on the graph. So I just put all the whole numbers in between there. Right, again, so second graph to get the points. See if you want to see what it looks like graph. Okay, and also point out the local minimum and the local maximum. There's one of each. Yeah, I would use 0, 1, 2, 3, 4, because once you get to 5 and 21, it's too big. On this one, I would use 0, 1, 2, 3, 4, not always. But remember, continue on past your points and put arrows on the end, okay? This playlist is called Future Funk, Alvaro. That's why it's funky, okay? So my graph looked like this. Okay, yeah, y'all got it like looking like that?
Yeah.
Yeah, who can tell me what's the local maximum?
1, 5.
We're at 1, 5, yep, that's what I'm hearing from 2 people, 1, 5, that's my local max. Okay, and I'm doing it in color coding, 1, 5. And then what is my local minimum?
3, 1.
3, 1, right. They're pretty easy to spot. Okay, and again, we're going to cut this down and tape it in later or glue it in later. Okay, so you can just leave the blank spot for that and we'll put it in whenever we get a chance. All right, and I'm going to flip it onto the next page, even though I have a little bit more space for the next thing. The next part is where we're going to put the other thing we're going to glue in. Okay, is this. Okay, and it just talks more about turning points. Okay, I'm going to break it down. It's just kind of a lot of words. I don't want you to have to write them all. Okay. It says the graph of every polynomial function of degree n has at most n minus 1 turning points. Okay, so what that means in English is if it's degree 3, it has n minus 1 is 2, 3 minus 1 is 2 turning points. Just like this one, it's cubic, it has 2 turning points. Okay, that's basically what number 2 is saying as well. Okay, if it has n distinct real zeros, then it has exactly n minus 1 turning points. So like 3 real zeros gives it 3 minus 1 is 2 turning points. And then they tell you the y coordinate is the local or relative maximum. Okay, another word for local maximum would be relative maximum because it's just like compared to the ones around it. Okay, and that's when the point is higher than all the nearby points. We just talked about that. Okay, local relative minimum is when the point is lower than all the nearby points. Okay, again, same. We already talked about that. Okay, one other thing that we're going to add on to this is increasing and decreasing. Okay, we've done this before. I know people are a little bit confused by it, so that's why we're going to keep doing it here again. Okay, increasing is the parts of the graph that look like they have a positive slope, like this. Okay, they're going up this way. Okay, we're talking about from left to right. So like on this graph, this part is increasing. Okay, this part in the middle is decreasing because it's got a negative looking slope. Okay, that part's decreasing. And this part is increasing. Okay, this one has 2 increasing parts and the part in the middle is decreasing. Where they change directions is at a local maximum or a local minimum because that's a turning point. Okay, so we're going to talk about how to figure those out here on the next one. We've got an equation number 3, y equals negative x cubed minus 3x squared minus 1. Okay, I think these are easier when they give you a graph, okay? But if they give you an equation, we have the calculator to give us a graph for this, okay? So, But also, totally you can sketch it on your paper if it's easier for you, okay? Because I think it's easier with a graph on my paper, personally. So we can put this in y equals, okay, negative x cubed minus 3x squared minus 1. And, oh, we're going to list, sorry, I need to write the things that we're going to put down. Okay, we're going to put our local minimum, right, our local maximum, our increasing intervals, and I'm going to put the parentheses S. That means it could be more than one or not, okay? Sometimes it might be more than one or it might not. And our decreasing interval. Again, it doesn't mean for sure there's an S on the end, but it could. So we're going to name two things we've already figured out how to do, and increasing and decreasing intervals. Where is it increasing and decreasing? Okay, the increasing and decreasing are talking just about the X values, okay? They don't worry about the Y values. So I'm just going to tell you that right now. They're just talking about on what X values is it increasing, between what X values is it decreasing.